Alright, sorry about that. Kinda had to cheat a little bit to realize that I was doing something. There's an easy answer. Can I print out a list of these guys? Boom. Alright, so that's the mean, that's the standard deviation. Let's see if this for loop works now. Boom, we did it. Alright. So if this is your first for loop, let's go over it. Actually, we don't even need these guys anymore. So even simpler. Classic for loop, for x in 1 through 10. So that means that it's going to start where x equals to 1 and do everything in this for loop. And then it's going to go, okay, now x is 2. Do everything in that for loop. X is 3 all the way to 10. So what this output is showing is, so x is equal to 1. Yeah, so we don't actually reference x in here, but that just means we're doing it 10 times in a row. We never actually see x turning, but we could if we wanted to. In fact, why don't we do something like that? Does that work? Boom. So this is what time we're doing it, and it's because vectors all have to be the same type. It's interpreting x, which should be an integer, as a really long floating point. But that's fine. 1, 2, 3 to 10. So that's, we're doing it 10 times, and that's the middle column is the mean, and the second column is the standard deviation. Okay. So let's see, if we only have 10 samples in our experiment and the true mean should be 0, we get a pretty big range. Wow, the mean is 0.8 that last time that we did it. That's crazy high. Very rare. But yeah, negative almost 0, 0.4, 0.2, so we get a range of, let's write this down, range from negative 0.01 to 0.8, which is huge range for the mean, when we know that the actual true mean should be 0. And now for the standard deviation, which should be 1, but since we only have 10 samples in our experiment, the range goes from, let's see, what's the lowest, 0.6 all the way up to 0.14. So that's the mean range. SD range from 0.6 to 1.4. All right. So let's do this 10 times for 100 sample experiments. So another thing about this for loop is that each time that this line is run, it's going to generate a new random set of numbers. So the way that the random numbers works is if I do it once, x1 is going to be those same numbers over and over and over again, because it's not rerunning that randomize the number function. It's just recalling that list that we made one time with that random number. So, but if we run it again, boom, those are going to be different numbers. If we run it again, then those are going to be different numbers. You see the difference? Okay. Yeah, I know he said make a matrix, but I mean, this, you can see it right here. This is pretty much looks like a matrix. If you wanted to, you could say something like, maybe that's a good example. So let's say output is this guy. The extra parentheses shouldn't matter. And then if we just call output, what happens? What happens? It didn't. It didn't. But output is now a variable that gets changed every time. All right, so that was not a great idea. Forget I said all of that. We'll go over making a matrix and then having like a for loop fill it out over time. We'll get to that later. But for now, pretty simple for loop. I'm not that great with making it look pretty, but it does it, right? So now we need to try it with 100 sample experiments. So in this, we kind of did a 10 sample experiment 10 times. So now let's do a 100 sample experiment 10 times. All right, sorry about the formatting, but boom. It's a bunch of numbers. Should be. No, we're only supposed to do 10 experiments. I changed the wrong numbers. Boom. Good catch, everyone. So 10 times, but with an experiment of 100 numbers. That's why it looked weird. There we go. All right, what's our mean range now? We got a negative 0.1, and we go up to 0.1. It's much smaller range. And then for the standard deviation range, we got a 0.98, 0.93, and then we go all the way up to 1.06. So much smaller ranges now that we basically increased our experiment size by 10 times. All right. We can do this again. 1,000. Yeah, we're doing it. All right, so is this right? Yes, yeah, that's right, sorry. Brain fart. Okay, what's our range now? Pretty darn close, basically 0 the whole time. What about this? Yep, again, pretty darn close. Oh, did he say 10,000? Yeah, skips from 100 to 10,000. So let me just throw in an extra 0 there. Pretend I did it right the first time. Yeah, 0.02 it gets to. 0.98 it gets to, but it's pretty much 0 and 1 for the means and standard deviations. All right, and that's it for problem number 3. We're almost done.